My name is Milto Miltiadou. I'm a lecturer in computer science, and today, if you've been to previous conferences, you've seen how Plot2Sat evolved. So the first time we talked like we're implementing it. Last year we were like, it's ready, but it's not published. Well, now it's published and we've got applications. So if you haven't been, it's okay. You don't need to know anything about it to understand. So Plot2Sat is a new tool that it solves the problem of extracting extracting an Earth observation time series from multiple regions. And this is very useful when we're working with plot data, because plot data, they're very small regions spread around a landscape to represent, for example, an ecosystem. But working through these small regions, it can be very time-consuming and expensive. So with Plot2Sat, it's estimated that I've managed to process an estimate of 18.3 terabytes of data covering the entire Spain over a year in less than 24 hours. And the published version of Plot2Sat currently works by taking as input the CSV files with the plot data. It creates the regions given a radius. There are some maps that can help you clean up a bit your data. You can choose whether you want Sentinel-1 or Sentinel-2 and export the data as multiple CSV files on your Google Drive. You download the data and convert them. And that was the first application. We briefly talked about it last year, where it's about using Plot2Sat to exploit the third dimension of the data, which is the time, to help us improve tree species classification, tree genera classification. And the main output here is that we find out that there are a lot of subgroups within the groups that we already have. So we need to investigate it further and understand how these are actually grouped to improve the model. And the main focus of the presentation, it's about the GreenSeed project that we work with ML4EO. So we heard yesterday about the forest part of the project. So here we're talking about comparison of JULES estimates with time series of Earth observation data. So the second area is green belts, which are areas around cities in the UK, and they're very important for policymaking because they help us support biodiversity and well-being, among other things. So JULES is a land surface model which extracts estimates 5,000 square meter resolutions, daily estimates, and we use it to extract soil carbon, vegetation carbon, and net primary productivity. And we calculated the average of each month for those three estimates. Now with the time series, we got the shapefile from the polygons defining the green belt. And they used the collection from Sentinel-1, this specific collection, because it's pre-processed by SAR, which means data has been, there is a terrain correction and all the other processing. Regarding Sentinel-1, a medial filter is applied afterwards, and that's important to reduce speckle noise. But one of the things that you need to know about, and that's important, that's as important like the previous person, the morning keynote, is some accuracy you're losing because the speckle filter is applied at the end and not as the correct processing applied line, which means you're losing some accuracy of your data. But if you want to work like in base scales, it is a trade between the two that you need to take. But it's important to understand those challenges that it's important to understand what you're taking and what you're losing when you're actually using Plot2Sat. And the other collection used is the Sentinel-2 collection. It's used to harmonize data because the data is being harmonized, as the name says, which means that the range of the intensities is consistent all the years. And regarding Sentinel-2, the level 2 data, they're already bottom of atmosphere, so it means they've been atmospherically corrected. And we're using cloud masking. So at first there are 2 levels of cloud masking that you can do. The first one, we're removing everything that is, all the images that are, in this case, 50% more clouds, and then the rest are the clouds are removed. And then we calculate, so we calculate the indexes for each available image. Then we calculate the one image for each month, the average of each month, and then the average of each polygon. But you may have realized right now, all the things I've mentioned that we're doing, there are 2 things that they're not part of the published version because they're additions that we did part of the project, and that's there are the 2 new things. One is that about the support that instead of just working with plots, we can work with shape files, and you can extract the time series of any polygons of interest. And then the other addition, which was done with collaboration with Finn, is the support of soil, water, vegetation indexes that they are added into the system. This is not published, but if you want to use it, the aim is to be published, which just needs some time. But if you want to use it, please feel free to reach out so we can share that and work out a way to use it. And to go to the preliminary results, so Finn did the correlations. There are some weak correlations with soil carbon. The correlations with vegetation carbons are casing stronger. The preliminary result, because I was still checking a bit of the indexes. And then the net primary product activity is becoming stronger, and you can see that the strongest correlation exists at the near infrared as part of the spectrum, which makes sense because it's very much relevant to vegetation, so that's a good insight about the result. And the other thing to see is that weaker correlations at the Burton upward trend green belt, and we suspect that this occurs because there are more urban areas within the green belt than green areas, which is why it affects the results. It's also worth mentioning that I'm quite happy with how people perceive the tool. I've started monitoring how much people are cloning the protozoates since a month ago. So since the 20th of May, there were like 22 clones in GitHub. So it means that it's slowly starting. It's published in April, so hopefully it will be used by the community more. And there are 2 projects. There are 2 people here working on these 2 projects, so you can go and approach them. Only they're working on forest size classification, and James worked on land cover classification for UNESCO size projections, and MSC project, small project. So just like we're still like at the beginning of the project, but it's really nice to approach them and get an idea of what they're doing. And there's also a Marie Curie funding that will work with time series starting in February, Benjamin. And it's about, we want to work on large-scale prediction of fires, of forest fires drivers. And there is a PhD opening that is related, so if anyone is interested, please let me know. Where it's about it's about large-scale ecological predictions of why the fires, how the forest fires are recovered faster. So it's like the postdoc is like before the fire, and the PhD will be after the fire. So it will hopefully create more collaboration, or we can work with different data depending on the candidate's interest. I'm also interested into 3D, so we may be interested into embedding biomass or JEDI into the project. Yeah, that's it. Any questions?
I've got a question while cogs are whirring. The evaluation of JULES, carbon uptake and storage estimates against remote sensing data. Given what we've been talking about confidence, uncertainty, application, this is slightly left field question. What do you think those findings shouldn't be used for?
Right now we're at the point of looking at correlations, so it's not about evaluation. So it's like how much like this, like satellite indexes relates with the JULES outputs. So it's, I mean, they're both estimates, so it's not like one is correct and the other one is wrong, that they can tell us like, oh, this is performed better than the other one. But when they're correlating at what we're expected, which was like the near infrared, we're more confident that that the JULES is doing what it's supposed to do. And that's what we want to go possible in the future, to use this Earth observation data to embed it into like JULES. Hopefully, we'll see. Yeah. Any more questions?
In that case, can everybody join me in thanking all four of the speakers? Sorry, 3 contributions, 4 speakers.